Hello everyone. In this video, we'll learn one of the most important topics in RCC design: development length of bar, as per IS 456. Let's understand what it means, why it's needed, and how to calculate it. When steel bars are embedded in concrete, the bond between them transfers stress. The development length is the minimum length of bar required to safely transfer the full stress from steel to concrete without slippage. This bond is a combination of chemical adhesion, friction, and mechanical interlock of concrete around deformations in the bar. According to clause 26.2.1 of IS 456, development length, denoted as LD, is given by the formula LD equals phi multiplied by sigma s, divided by 4 times tau BD, where each term has specific meaning. Here, phi is the nominal diameter of the bar in millimeters, sigma s is the stress in the bar at the design load, and tau BD is the design bond stress between concrete and steel. The values of tau BD are provided in table of IS 456. For example, for M20 concrete with plain bars, tau BD is 1.2 Newton per square millimeter. For deformed bars, we can increase it by 60%, that is, 1.9 Newton per square millimeter. As per the code, for bars in compression, the design bond stress tau BD is increased by 25%. That means, compression bars require a slightly smaller development length. Let's take an example. Suppose we have a 20 mm diameter deformed bar, phi equals 20 mm in M25 concrete, with Fe 415 steel. For Fe 415, sigma s equals 0.87 times Fy equals 0.87 times 415 equals 361.05 Newton per square millimeter. For M25, tau BD equals 1.4 Newton per square millimeter times 1.6 equals 2.24 Newton per square millimeter. Substituting in the formula, LD equals 20 times 361.05 divided by 4 times 2.24 equals 805 mm, or approximately 40 times phi. Hence, the required development length for this bar is 805 mm. In design, the required LD can be achieved using 1. Straight embedment length, 2. Hooks or bends, and 3. Anchorage in adjoining members like columns or slabs. You must check for sufficient development length at all member joints such as beam column, column foundation, slab beam, etc. and at all lap joints. If the bar is cut too short, it can cause bond failure or cracks. To summarize, LD equals phi multiplied by sigma s, divided by 4 times tau BD. Increase tau BD by 25% for compression bars, and by 60% for deformed bars. Use following table from IS 456 for different concrete grades. Thank you for watching. Don't forget to like, share, and subscribe for more structural design tutorials. In the next video, we'll discuss anchorage length and lap splicing closely related to today's topic.